see if we can identify for a particular number its opposite. So here we go. The first one is 2. So if we plot 2 on this number line, that's positive 2. How do we find its opposite? Well, it's going to be the same distance away from 0, but on the other side. And so what I see here is it'd be right here. And so the opposite of positive 2 is actually negative 2. Cool. Let's try another one. Let's take a look at the number negative 3. What's the opposite of negative 3? Well, here what I've got to do is find the point that's the same distance away from 0 as negative 3, but on the other side. So that's going to be 3 units in the right direction. And so I get to here. That's positive 3. And so we can see that the opposite of negative 3 is positive 3. I'm seeing a pattern. I'm seeing a pattern. There's one real strange example that I wanted to share with you. This one's a real oddball. What about 0? What's the opposite of 0? Well, if you think about it, the definition says we go the same distance away, but on the other side of 0. But this is 0. So it turns out the opposite of 0 is itself 0. It's the only number whose opposite is the same thing as itself. Fun. Gotta love the 0. Before our own eyes, let's take a look at an example. So here I have 3 integers, 5, negative 3, and 2, and I'd like to order them from the smallest up to the largest. So we might have to actually rearrange these things, and so actually I'm going to, right now, allow us to move them around by using the cutting property of mathematics. That's just a joke. There's no cutting property of mathematics, but there's a cutting property of scissors, and you should never run with them. Okay, so here we go. Now, how would you order them? Well, I'm just going to put these numbers on the number line and see where we go. So 5 is way off to the right. That means that's pretty big. 2 is a little bit to the right, but not as far to the right, so it's smaller than 5. And negative 3 is way off to the left. And so therefore, when I see this, this automatically gives me the ordering. Negative 3 is the smallest of the 3 numbers. 2 is in between. And 5 is the largest. And so the ordering would, from smallest to largest is negative 3 to 5. And we can see that by seeing their locations on the number line and reading from left to right. Let's try one more. So here we've got a bunch of them. Negative 1, 1, negative 4, and 0. So I use the cutting property. Aren't numbers a real cut up? Okay, so now we have the numbers. And now let's put them on the number line. So let's see. So negative 1 is just a little bit to the left of 0. 1 is a little to the right of 0. Negative 4 is way off to the left. And 0 goes right in between. All right, well, now that we have this ordering, this actually tells us smallest to largest. Negative 4 is the smallest, moving from left to right. Then we get to negative 1. Then we get to 0, and then we get to 1. So the ordering from smallest to largest is negative 4, negative 1, 0, and finally 1 is the biggest. Very cool. That's the power of ordering using a number line. So let's compare integers and figure out which one is bigger than which one. So here, for our convenience, I've drawn a number line, and you can see that, we have 0, and then as we move to the right, 1, 2, 3, 4, and then as we move to the left, we get the negative numbers, -1, -2, -3, -4, and they're getting smaller and smaller and smaller whenever I move to the left. Numbers are getting larger and larger and larger whenever I move to the right. So let's actually figure out the appropriate inequality sign that we should put in between these two numbers. So I see 1 and -2. So let's check them out. I see 1 is here and -2 is here. So since 1 is to the right, 1 is larger. So 1 is greater than -2, and we would indicate that with this symbol. 1 is greater than -2. Great. Let's try this one. Let's compare -3 and -4. So let's check it out. So here's -3, and here's -4. And since -4 is to the left of -3, then -4 is the smaller one. The number that's the most left is the smallest. So therefore, I see that -3 is larger than -4. So I'd write this as -3 is larger than -4. And that seems a little bit funny, doesn't it? Because normally you think of 4 being bigger than 3. That's true. But when you have these negative signs in front, then in fact the opposite happens. And so we see that -3 actually becomes larger than -4 because the -3 is now to the right of -4. Let's try one last one together. Let's compare -5 with 0. Well, let's see. Here's -5 way off here on the left. Here is 0 right here. And so which one is the bigger one? Well, 0 is bigger. -5 is to the left, and so it's smaller. So -5 is smaller than 0, or we say in math terms, -5 is less than 0. And we denote that with the less than symbol, which looks like that. So we see -5 is less than 0. So here are 3 inequalities involving integers, and we're able to figure these inequalities out by remembering that if a number on a number line is to the left of another number, then that number is smaller than the second. It's actually really easy to find the absolute value of an integer because all that represents is the distance that that integer is from 0. So just a distance. Absolute value is a distance. Let's take a look at an example. Let's find the absolute value of 2. What do? What I do is I look at 2, and I want to measure the distance from 0 to 2. And what's that distance? Well, that distance is 1, 2. So the absolute value of 2 turns out to be 2. No problem. Absolute value, you have to remember, is distance. Let's try another example together. Let's find the absolute value of -3. Well, where's -3 on the number line? -3 is right here. All I'm looking for is the distance between -3 and 0. So I just count. 1, 2, 3. There are 3 units here. So the absolute value of -3 is 3. The important thing to remember about absolute value is that it's measuring a distance, so absolute value can never be negative. It's always going to either be 0 if you're measuring the distance, the absolute value of 0, or it will be positive if you measure the absolute value of any other number. So absolute value is always positive, and it represents the distance a number is from 0. No problem at all. Neat absolute values.